Class example 3.5.1, we're now into linear relations. So we know linear means that it's going to be in the form of a straight line, but we also know that in a linear relation, we have a consistent or a constant rate of change. What does that mean, a constant rate of change? That means that we have to be consistent in our inputs and outputs and how much they are being affected. So when we look at these two tables here, we see which table of values represents a linear relationship. First of all, in A, we have the relation between the number of bacteria in a culture, which is N, that's the number of them, versus time in minutes. So we're just going to look at how often we're actually adding or measuring these bacteria. So we have time 0 to time 20, that's going to be 20 minutes. Time 20 to time 40, that happens to be another 20 minutes. 40 to 60 happens to be another 20 minutes, 60 to 80, and so on. And we can see that we are actually being constant in the actual increases for our input. But what makes what makes a linear relation is when you have a constant input that you have a constant output as well. So we're going to look at the number of bacteria. It went from 1 to 2, so it increased by 1. Then it went from 2 to 4, which increased by 2. Then it went from 4 to 8, which increased by 4. Then it went from 8 to 16. And we can see, in this particular case, this is not constant. Okay, it's increasing first by 1 and then by 2 and then by 4. So it's actually doubling, but that's not a constant rate of change with regards to a one-to-one relationship. So this is not a linear relation because the consistency of the inputs and the constant rate at the inputs of 20 minutes per time is not being reflected in the number of bacteria culture that are being counted. For question B, let's take a look at the relation between the amount of goods and service tax charged, which is T, so this is the amount of money being charged, for the amount of the purchase amount, so that's the dollar amount for the actual purchase price. So let's just see if it's going to be consistent in our inputs. We can see that it's going from 60 to 120, 120 to 180, 180 to, oopsie, sorry, that's a 60, 240, 240 to 300. So if we look at every $60 increment, 60, 120, 180, so $60 increments, does the actual tax amount increase by the same amount for each $60? So if it was $3 for 60, then it went to $6, that's an increase by 3. Then it went to $9, that's another increase by 3. And then it went to 12 and so on to 15. I can see that I have a consistent rate of change for both the input and the output, which means that this will form a linear relation between the amount of goods and service tax charged and the actual purchase amount.